Hello, everyone. Today we're going to do lesson 4, Finding Limits by Analytic Methods. I'm going to start doing a little bit of your notes ahead of time, some of the longer notes that you'll be taking, not necessarily problems, to hopefully cut down a little bit on your time. Now that will mean that you will need to pause the video so that you can take your notes. But in this format, the actual video itself should not be that long. Today's lesson is a longer lesson, so I'm going to do your video in 2 parts. As if I were teaching you in class, we would do part 1 one day and part 2 a different day. But I'm going to go ahead and do them in 2 parts as well so that you will know kind of where the stopping part is and the starting point of the next day. So finding limits by analytic methods. If you look here in this first highlighted box, it tells you the different methods you would use to solve and find limits analytically. That means using algebra. Direct substitution, that is your goal. If every problem was direct substitution, this would be very, very simple, but they're not. But ultimately, your last step should be direct substitution. Basic limit theorems, which we talked about yesterday. Factor and cancel, and then direct substitution. Rationalize the numerator, then use your theorems, and then use direct substitution. Special trig limits. These are limits that you will need to make sure that you know. If you are able to convert your limit to the sine of x over x and your value that you are approaching is 0, the answer is 1. You don't have to do anything else to it. It's just a substitution. The other one is the limit as x approaches 0 of 1 minus cosine x over x, and that value equals 0. So those are 2 things you will need to make sure that you know. And then L'Hopital's rule, which we will study at a later time. The substitution theorem says if f is a polynomial function or a rational function, then the limit as x approaches c of f of x equals f of c, provided that if f is a rational function, the value of the denominator does not equal 0. That is basically saying if you have a rational function or a polynomial function with no denominator, you should be able to use direct substitution in order to find your limit. Notice your note, always try direct substitution first. If you get 0 over 0 or infinity over infinity, which are both called the indeterminate form, the goal will be to simplify the expression using algebraic techniques and then try substitution again. So as you look here for problem number 1, and you will probably want to have a unit circle handy. I have put a unit circle under Files on Canvas. Or you can just go to Google and Google unit circle and one will pop up. We have a polynomial function here, so direct substitution will work. 3 times 2 squared minus 5 times 2 plus 4. 3 times 4 is 12. 12 minus 10 plus 4. 16 minus 10 is 6. Part B does have a denominator, but as you notice, when you plug a 2 in for x, it does not make that denominator equal to 0. Therefore, direct substitution will work here as well. 2 to the 3rd power plus 1 over 2 plus 1. 8 plus 1 is 9 over 3. Simplify, and your limit is 3. We have a natural log function here. The limit as x approaches e is ln of e over 3e. Something you will need to remember, ln of e is equal to 1. Don't forget that. So 1 over 3e is your limit. You do not need to evaluate that as a decimal. 1 over 3e is fine as your answer. If you would like to pause, you are welcome to work D, E, and F and then come back and check. Part D, cubic root of 4 plus 4, cubic root of 8, which is 2. We do have a trig function here in part E. Substitute sine of 2 times pi over 6 is the sine of pi over 3. Now, you do not want to rush to get your calculator here because we're not looking for a decimal answer. We're looking for an exact value from your unit circle. On your unit circle, the coordinates at pi over 3 are 1/2 square root of 3 over 2, quadrant 1. Everything is positive. Remember, cosine is your x and sine is your y. So the answer is the square root of 3 over 2. This would be a problem that would be a non-calculator active problem, so you would be expected to be able to do that with your unit circle. And then for part F, log base 3 of 5 plus 4 is log base 3 of 9. Remember your properties of logarithms. Set this equal to x and do your circle. 3 to the x power equals 9. So x is 2, which would be your limit. All right, at the top of your next page, topic 1.10, exploring types of discontinuities. This is where you're going to want to pause your video so that you can take your notes. I'm just going to walk through them quickly and then head on into the next section. What is the process for finding discontinuities of a rational function from pre-cal? Number 1, factor the numerator and denominator and simplify. Number 2, a point discontinuity occurs when factors are removed or you've canceled them out. When that value is equal to 0, that factor that you have canceled, where does that equal 0? That point discontinuity is a hole in the graph. Number 3, a non-removable discontinuity occurs if factors don't cancel in the denominator when x minus a equals 0. That means when you have a factor left after you've canceled everything that you can, set that factor equal to 0, and that result is a vertical asymptote. So looking here, factoring method or cancellation technique, we're going to look at that here for this example. So we're going to keep our limit notation, and for some of you, I know that's going to be tedious, but you keep the limit notation in your problem throughout until you can use direct substitution. Not doing that will lose you some points on each problem. Factor the top. What multiplies to give you -6 and combines to give you +1, 3, and -2. Factor the bottom. What multiplies to give you 8 and combines to give you -6, -4, and -2. X minus 2s are the same, they cancel. A whole would be at x equals 2 if we were looking for that. We're not, we're looking for the limit. But a whole would be at 2, a vertical asymptote would be at 4. At this point, you use direct substitution. 2 plus 3 over 2 minus 4. 5 over -2. Bring your negative to the top. Your limit is -5/2. We will be using fractions for the most part, not decimals. So as we look down here at the bottom, you will notice that we have the exact same function that we just factored and simplified, but now we're looking at it graphically. So here is our function as x approaches 2. Remember, as x approaches 2, you are looking from the right and from the left. So as x approaches 2 from the left and from the right, we know that that whole coordinate is 2, -5/2. We are looking at our y value, which is -5/2. Same function as the limit as x approaches 4, vertical asymptote, from the right. Approaches +infinity. Limit as x approaches your vertical asymptote at 4 from the left, -infinity. So what would happen if you tried to evaluate this limit using direct substitution? The direct substitution leads to 0 over 0, which once again is your indeterminate form. Remember, when you get indeterminate form, 0 over 0 or infinity over infinity, your goal is to algebraically manipulate the expression in an effort to remove the point of discontinuity. Then try direct substitution again. Let's explore a few techniques. That's pretty important. Your goal is to algebraically manipulate the expression in an effort to remove the points of discontinuity and then try direct substitution again. So in other words, if you have a 4 here and you plug that into the bottom and it gives you 0, you want to see if you can algebraically manipulate. That means using factoring and canceling, using rationalizing the numerator in order to get rid of that factor. So we have the exact same function. We've already factored it. When we simplify, it's x plus 3 over x minus 4. But we have a different value here, and if we plug that value in, it gives us 0. So as x approaches 4 from a positive direction, pick a value to the right of 4. So think about a number line. And if that number line were to continue, you would want a value to the right of 4 if you're approaching from the right. Now, I typically go a tenth above. You do what you would like. We're looking for a sign value, positive or negative. So to figure out what our sign value would be, you plug the chosen value of x in for x in your limit. So 4.1 plus 3 over 4.1 minus 4. Again, you're looking for signs, positive or negative. So 4.1 plus 3 is going to give you a positive value. 4.1 minus 4 is also going to give you a positive value. Positive over positive equals positive. That lets you know that your answer will be infinity with a sign that you found, in this case, positive infinity. Now, obviously we could graph that and figure that out, but if this is a non-calculator active assignment, you have to know how to do it without a calculator. This time we're looking from the left. X plus 3 over x minus 4. This time you are going to pick a value to the left of 4. Again, I go a tenth above or below, so here I would pick 3.9. So 3.9 plus 3 over 3.9 minus 4. Positive value on top, negative on the bottom, gives a negative result. Answer, your limit will approach negative infinity. So then we're just going to fill in our boxes here at the bottom. Again, mark with sticky notes or a different colored pen if you have questions. All right, piecewise functions. Piecewise functions means comes in pieces and it has constraints. If x is greater than 1, this is the same as the limit approaching from the right. Less than will be approaching from the left. Find the limit. So the limit as x approaches 1 from a positive direction of the function means I focus on the first piece. I plug a 1 in for x, and 1 plus 1 is 2. Then I do from the left. This time you concentrate on the bottom function, and 1 plus 1 is equal to 2. Notice your limits from the right and from the left are equal. Therefore, the limit as x approaches 1 of g of x is equal to 2. Why don't you pause the video, try part B, because you're going to do it the exact same way, and then come back and check your work. X is less than or equal to 2 is 2 from the left, greater than 2, 2 from the right. Find your limits. Two squared minus 4 times 2 plus 7. 4 minus 8 plus 7 is 3. Find your limit as x approaches 2 from the right. Negative 2 squared plus 4 times 2 minus 1. Negative 4 plus 8 minus 1 is 3. Limit from the left and from the right are equal. Therefore, the limit as x approaches 2 of the function h of x is equal to 3. We're going to do a little bit of practicing on the next page. Again, if you would like to stop the video, do your work, and then check your work, you are welcome to do so. Part C is a little bit tough. Factor. And even if you want to try direct substitution here, you can. But if you go ahead and factor, that direct substitution will be very clear as to whether or not you can use it. So x plus 3, x minus 2 over x minus 4, x minus 2. We're pretty familiar with this function at this point. 2 plus 3 over 2 minus 4. We've already actually done that one, negative 5 halves. So that one should have been pretty quick. Now you may need some refreshers on difference of cubes. Don't forget that limit notation stays with your problem and your function until you use direct substitution. So x cubed minus 27, both perfect cubes. Subtraction in the middle means difference of cubes. So you have a small set of parentheses and a large set of parentheses. Your signs are same, opposite, and plus. Cubed root, square the first, multiply them together, and square the last. Factor the bottom. Cancel. Substitute. Answer is 27 over 7. You have 4 terms in the numerator and denominator for part C. That means usually grouping. Keep that limit notation with you. And in the numerator, we have a GCF first and second. So GCF of the first group, what's left? GCF of the second group, what's left? And then when you simplify that, you get what they have in common and what's left. Now, as you look at the denominator, you can see the first 2 have something in common and the second 2 do not. So, when grouping doesn't work, use synthetic division. What goes in the half box is what x is approaching. List the coefficients out to the side. 1, 2, negative 13, and 10. Skip a line, draw a line, and bring down. Multiply and combine. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. Negative 13 plus 8 is negative 5. 2 times negative 5 is negative 10 with a remainder of 0. You should expect to have a remainder of 0. Take your coefficients and plug them into your answer, starting with a variable with an exponent 1 less than what you started with, results in x squared plus 4x minus 5. That's what's left. You also have to incorporate the function that you used, which is x minus 2. So you might want to make your own individual notes on that according to what you need. Cancel and substitute to complete the problem. We're plugging in 2, so 2 squared plus 5 over 2 squared plus 4 times 2 minus 5. On top is 9. 4 plus 8, 12. 12 minus 5 is 7. Answer is 9/7. Again, if you have specific questions, write a sticky note, write your questions on there, or make a note where your question is so that we can accommodate that when we get on Zoom or email or office hours. All right. When we are looking at example 4 with complex fractions, a complex fraction is simply a set of fractions inside of another fraction. You will need a common denominator, which I find using something I call cross, cross, across. I'll show you how that works. So we have the limit as x approaches 0, the x on top stays on top. To find the common denominator quickly, you do cross, cross, across. So 1 times x minus 4 is x minus 4 plus 4 times 1 over across. And you found your common denominator. In a complex fraction, you multiply by the reciprocal of the denominator. So this problem becomes the limit as x approaches 0 of x times 4 times x minus 4 over x, because negative 4 plus 4 is 0. X's cancel. Plug in a 0 for x. And 4 times negative 4 is negative 16. If you would like to pause the video and try part B, it's very similar. You're still going to use cross, cross, across. This time the reciprocal of the denominator is just 1 over x, and then you will substitute. The limit as x approaches 0, cross, cross, across. Don't forget to distribute the negative. You get 2 minus 2 plus x over 2 times 2 plus x. And then multiply by the reciprocal of the denominator times 1 over x. A little bit of algebra here. So this is 2 minus 2 minus x, which leaves you with negative x over 2 times 2 plus x times 1 over x. Continue to keep that limit notation. Simplify by canceling, and you get negative 1 over 2 times 2 plus x. At this point, you are ready for direct substitution. Negative 1 over 2 times 2 plus 0. Answer is negative 1/4. All right, we are going to stop the video, give you guys a chance to figure out what you have done and what you have looked at, and analyze your material to see if there's something that you have questions on. This will start part 2 of section 1.4, and we will start that in our next video. If you are choosing to do the second part of your video at a different time, I hope you have a good day today and a good day when you get back to part 2.